modern equivalent of the ether? And I'll say no. Where the ether came from, so what the ether is, in the late 19th century, we had, physics was beautiful. We had great theories of everything, and in fact, many physicists felt like we were almost done, that we had almost explained everything. Well, some of the things we had were Newton's laws, which told us, and Newton's laws applied to all kinds of stuff, could explain wave motions, like the waves on the ocean you can explain with Newton's laws. You can use Newton's laws even to explain sound waves through the air. Yeah, not entirely, but mostly. It's great. We also had this great theory of electromagnetism. Now, there was a little problem, though, that said that electromagnetism gave us a certain particular speed that light moved at. And what is that speed relative to? Well, electromagnetism didn't really tell us. Newton's laws always say if you have a speed, it has to be relative to something. And light said, light's moving at this speed, and what is it relative to? So people, not knowing how to deal with this, invented the ether as the thing that light is waving. Okay? Now, and yes, you can draw an analogy and say, okay, you had some things where your observations and your theory didn't make sense, so you invented new stuff. You invented new stuff to explain and make all your observations work right. Okay, kind of the same thing as dark matter. The difference is, ether was invented to explain a contradiction which we were able to resolve theoretically with relativity. What's more, there were direct experiments. The ether made predictions. Okay, if there's really an ether, then at different stages in the Earth's orbit, we ought to see different speeds of light going in one direction and the other direction because we're moving differently through the ether. Yeah, the Michelson-Morley experiment. The experiment was one and we didn't see it. Now with dark matter, there are predictions made. For example, if you have non-baryonic dark matter and two galaxy clusters collide, most of the dark matter should, and thus most of the mass, should just pass through each other and not collect in the center. Well, we did that experiment and we saw the result. So dark matter, predictions have been made for dark matter that have been borne up. So dark matter, we have a lot of evidence for dark matter. It's not just an accounting problem. It's not just, I can't get everything to work out, so I'm going to add dark matter. At this point, we have a whole bunch of stuff that needs dark matter to be explained, right? It'd be like trying to explain why things fall to the earth without using gravity, all right? Well, Aristotle did that. He didn't, his idea of gravity was that everything had a natural place and heavier things' natural place was lower. But that doesn't explain about the stars orbiting the sun, and eventually we explained all that with gravity. Nowadays, dark matter explains so many different things that it's not just an ad hoc, we can't explain this. It explains many different things, and it has made predictions that have, yes, the spaghetti monster. Dark matter theories have made predictions that we've then later observed. So dark matter is very different from the ether, and that we know it's there. That's right. George says also independent lines of evidence, whereas the ether was based on one sort of conflict, one discrepancy. With dark matter, we've looked at it a whole bunch of different ways. Yes, intelligent falling theory. I recommend you search that on the web. It's an Onion article from about 6 or 8 years ago about intelligent falling. That really explains gravity. Any other questions? If not, I think I'm going to go ahead and have lunch because I'm kind of hungry. Do I want to show my cartoon? Sure. The cartoon was all about Mond. All right, thank you all for coming.